Welcome to The Explainer. Today, we're diving into a really cool paper that uncovers a shared secret between your brain and the most advanced AI out there. And it all boils down to one simple idea: prediction. Could that really be the key to all intelligence? Let's find out. So, let's kick things off with a puzzle that has stumped scientists for ages. How can one simple, repeating design be so ridiculously versatile? And I'm not just talking about AI. This question applies just as much to that biological marvel inside your own head. And that brings us right to our first big idea, this universal circuit mystery. We're going to uncover a pretty profound similarity between the way our brains are built and how we're designing general-purpose AI. Okay, just think about this for a second. Inside your head, you've got these two massive structures, the neocortex and the cerebellum. I mean, together they make up over 99% of your brain cells. And yet they somehow handle everything: seeing, hearing, moving, thinking, all with a surprisingly uniform repeating circuit. How on earth does that work? And, it's the exact same puzzle that AI researchers are wrestling with. You take a single scalable circuit like the transformer that powers stuff like ChatGPT, and it can process language, create images, plan actions, the whole shebang. It's a general-purpose circuit, just like in our brain. The real mystery is, how can one design do so much? Okay, so the first huge clue to solving this mystery lies in a fundamental job the brain has, one we're only now starting to really get. See, your brain isn't just a passive sponge soaking up information. Nope. It's an incredibly powerful, relentless prediction engine. Neuroscientists actually have a name for this. It's called predictive coding. And the theory goes like this: your brain isn't just sitting back waiting for stuff to happen to it. No way. It's constantly on the front foot, actively predicting what you're going to see, what you're going to hear, what you're going to feel next. And this diagram here shows you exactly how it works. Your neocortex is always generating predictions about the world. When the actual sensory info comes in, your brain compares it to the prediction. If they match, great, nothing to see here. But when they don't match, when reality surprises the brain, that's what we call a prediction error. And that error signal is the newsworthy bit of information that really drives learning. Okay, and here's where it gets really interesting, because this connects directly to AI. This quote here points to a pretty stunning convergence. The wild success of models like GPT, which, remember, are trained by just constantly predicting the next word in a sentence, has actually pushed neuroscientists to think, wait a minute, maybe our own brains are doing the exact same thing to learn language. So here's the crucial point. What happens when a system, I don't care if it's biological or artificial, spends all of its time and energy just making predictions about the world? Well, it starts to build something absolutely incredible inside itself. It builds what scientists call a world model, and you can basically think of this as a VR simulator of the world running inside your head. It's not just a collection of memories of stuff you've seen. It's an internal model of the underlying rules of how the world actually works. And this model is so much more than just a scrapbook of memories, right? By learning from billions and billions of tiny prediction errors over time, both our brains and AI start to build this powerful, abstract model of reality. And that's how they go from just having specific experiences to grasping generalized rules and concepts. Okay, so here's the big payoff. This single, powerful world model that's built from prediction, it doesn't just do one thing. It actually unlocks three incredible and seemingly very different abilities, all from one unified system. So first, you get the core function, prediction, just guessing what's going to happen next. Second, you can use that same model for understanding to interpret what's happening right now. And third, you can flip it around and use it for generation, repurposing that predictive engine to plan your own actions or generate totally new things, like a sentence. And we see this unified system everywhere, in both AI and neuroscience. On the left, you've got the GPT architecture, built from the ground up for next word prediction. But look at the right. That's a model of the brain's cerebellum. And what's just mind-blowing is that when scientists trained this cerebellum model on the exact same next word prediction task, it spontaneously learned to understand complex language rules. That's huge. It shows how prediction just naturally leads to understanding and generation, all from one single process. This whole idea has this really cool parallel in neuroscience called the mirror neuron system. Get this. The very same circuits in your brain that fire up when you watch someone else do something are the exact same circuits you use to plan to do it yourself. It's a perfect biological example of a single model doing double duty for both understanding someone else and generating your own actions. So, this deep parallel we're seeing between brains and AI is not just a coincidence. It's actually a stunning example of what scientists call convergent evolution. That's when two totally different systems, in this case biology and technology, independently arrive at the exact same elegant solution to the same problem. In this case, the problem of intelligence. And you can literally watch this evolution happen in the history of AI. If you look back, early models had separate parts for understanding language and for generating it. But over time, they evolved. They moved toward a much simpler, way more powerful design, like GPT, that unifies everything through next word prediction. They basically, and completely unintentionally, ended up mirroring the brain's own strategy. So what's the secret ingredient that makes all this possible? Well, in both the brain and in AI, the answer seems to be one thing: sheer massive scale. The human brain has something like 100 trillion connections. And it's that kind of incredible scale that allows these really complex abilities to just emerge from a simple repeating learning rule. So if you take one thing away from this, it should be this: intelligence, whether it's biological or artificial, probably isn't a giant bag of different tricks. Instead, it seems to be built on a few core shared principles. 1. Learning is driven by prediction error. 2. A single world model is all you need for predicting, understanding, and generating. 3. You need things like attention to be flexible. And 4. Massive scale is what makes the magic happen. And all this leaves us with a final, pretty provocative thought. This deep convergence between brains and AI, it really suggests that the core principles of intelligence might be universal. Maybe it's just a fundamental property of how complex systems learn. So as we continue to build these artificial minds, are we really building some new alien kind of intelligence? Or are we just rediscovering the blueprint for our own?